So we're going to start up with session 3, the PACE applications session. So this is the session we're going to get some updates on the PACE applications program. We're going to give you some resources for how to join the community and stay informed. And we're going to give, Morgaine's going to start up with our first talk, and then we're going to have 3 more speakers to give their applications real-world examples. So I definitely don't need to introduce Morgaine, but welcome her up to the stage. She'll be talking about PACE Applications Program in the post-launch era. And for the speakers, I've got a little 2-minute warning for you, so I'll just flash it at you when you are ready to go. But everybody, welcome Morgaine.
All right, so in this talk, I know that a lot of you are familiar with the PACE Applications Program, and there actually are several of you that are not. So I've tried to balance between being expedient and useful with the description of our program, and also with some changes, kind of what we're looking forward to in the next year. Before I start to talk, though, I do want to say that when I was looking at registration, like I said earlier, I've noticed there was a lot of data questions, and once I noticed that, I put a couple slides here in the beginning before my talk that are just slides I want you guys to have for your reference. It's reiterating stuff that Jeremy and Alicia had in their talks, which is absolutely fine. I decided not to take it out when I saw that. I think that that's good because so many people said, "Where do I get PACE data?" I actually, people said that in the registration. So I want people to know what kind of resources are out there right now. I'm going to just help underline it all. So this is a slide that has a summary of kind of links with questions like, what should I know about PACE data? What's the current version of the data? Questions like this that are really useful for getting started with the data. The tools, that's just the list of the tools where you can go find data. And this is a list of places where you can get kind of the newest tutorials that we've released in the past about year. So tutorials like the one where it says Jupyter Notebook tutorials, that part has now become the Help Hub that you guys have heard about earlier. This is the same link for the Help Hub. And it now has, that's why I put and more. And so we also have CDAS tutorials, and then that NASA RSET course. And I wanted to underscore that because it was a course we were pretty excited about. And if you're interested in getting especially any OCI data, if you watch, the second part of it is about data access and goes over the links that I just showed in more detail. And they also have a CDAS demonstration in the end. And so that can be useful whether you're doing, water quality or other products. It's informative if you want to get data to use this, to go do especially the middle part of that course. And it's in Spanish too, which is great. And the Help Hub. So I just wanted to underscore these as really great resources for those of you that asked a lot of data questions in the registration. And now I'll move into talking a bit about the PACE Applications Program, as well as a look at where it's headed now that we've got PACE up there going around our beautiful Earth. So the PACE Applications Program, it's an interface between project science and end users. And the aim of this connection is to promote and advance applications of PACE data that benefit society. What's happening? Oh, I was wondering, what? Did I do it? I guess it was my dongle. Bad dongle. Okay. So, anyway, I had the question before, what are applications? What does that even mean? It's innovative uses of NASA PACE data products that have some kind of actionable impact. It's someone on the ground using the data to do something, to make a decision. And I don't mean like a scientist on the ground using it to do analysis, which is fantastic and awesome. It's the application that helps influence, policy-making, decision-making, and things like that. Applied research is really the bridge between, scaling foundational NASA science and technology with end users. And these communities of end users can be individuals and groups, public and private sectors, national and international organizations, at local to global scales. Oh. Ensuring the dongle's good. So, and I want to point out the image on the right is showing us the interdisciplinary nature of PACE applications. Just like, of course, PACE is, Earth system data, Our applications go across the Earth system, touching on so many thematic areas like Erin was saying earlier. It's a really fantastic attribute of PACE. One of our biggest goals, if I was going to try to say it in one sentence, is to accelerate and support translation of PACE's advanced data into societal action across all of these thematic areas. There's these 3 goals. We've had this slide for a little while, but it's building new partnerships, increasing accessibility and actionability of data, and demonstrating the societal value of PACE. So far in my time here in this the post-launch period of PACE, we've done a lot on trying to increase the accessibility and actionability of PACE data. Getting out there, getting tutorials out there, talking to people about data, doing what we can, because you need data uptake in order for people to do something actionable with data. And in the coming year, we really would like to reach out and find new end users and kind of understand, are there spaces that we're not in that we could be? What kind of ways could we serve different user communities that aren't being served? That's going to be a big question, and I'll have feedback questions for you guys on that as well. See if you have ideas that can help us with building these new partnerships. The 3rd goal is not being neglected. It is always important, but we have to get the data out there in order to show what we're doing with it. As far as some tangible examples of what can we do with PACE data in terms of applications, I have one slide each for matching the subject areas, the broad subject areas of our talks. So terrestrial, aquatic, atmospheric, the talks that are after this one. So for monitoring and managing terrestrial ecosystems, PACE provides data on surface vegetation, and this data can give us really interesting insight on the photophysiology, the primary productivity, and other dynamics of the terrestrial vegetation. And it helps us better, it's anticipated to help us better monitor things like wetland ecosystem health or forest health, agricultural practices, maybe even at least at a regional scale. This is something that Fred is going to be talking a bit about entirely talking about in his talk with the fantastic data that he has, data products to show, like this modified anthocyanin index. What it's essentially doing is these are hyperspectral enabled vegetation indexes. What that means is, because we have the hyperspectral, these are just kind of ratio algorithms that just take a couple points in the spectrum, right? They don't use the whole visible spectrum. They're not using a big spectral fingerprint. But they're important because, we need the PACE data because we can go look at different kind of colors in the spectrum. We can do these band ratio indices at different points of the spectrum. That's what we mean by hyperspectral enabled. So, and that's what these new vegetation indexes are about. So I'll let Fred, tell you all the fun stuff about that. But so there's terrestrial applications. There's, of course, the many water resources and water quality examples. Of course, we look forward to seeing how this is going to advance water quality management and understanding of aquatic ecosystems by doing things like better tracking and identifying harmful algal blooms, better assessing fisheries and aquaculture health, which is what this tool is about. It's a National Oceans and Coastal Information Management System decision support tool, and they're hoping to use PACE data to improve the quality of their tool, improve its accuracy. And we're also looking forward to evaluating maintaining ecosystem health, perhaps identifying oil spills, and maybe also post-disaster water quality impacts, like high influxes of sediment or huge harmful algal blooms. In the health and air quality zone, PACE collects aerosol measurements that can support the understanding of air quality and its implications on human health. And some examples of that, one thing that we're looking forward to is better understanding the influence of aerosols on the climate and on climate modeling. Of course, climate modeling is important to all of us to have good climate models. This will help reduce some of the uncertainty in the atmosphere component. Also providing air quality information to underserved regions that lack the kind of the high quality ground infrastructure that a lot of air quality monitoring agencies like, say, here, use in order to make public health decisions. Some places just don't have ground stations, and even though satellite air quality data isn't perfect, it's better than nothing, and so there's different groups looking into how that may serve certain communities. We also have one of our early adopters who, Marcela Loria Salazar, sorry if I got her name wrong. One of our early adopters is doing a really interesting work in Oklahoma, looking at if she can better inform regional health alert forecasts that are related to pollen, dust, and smoke in the Oklahoma and kind of general Southern Plains region. And she's doing this by leveraging the fact that, satellite data is often really powerful when you compare it with some really great ground data. So she has, right here, this map is showing Mesonet, which is this fantastic high-density meteorological stations that are all over Oklahoma. There's one in all of the 77 counties. And she pairs it also with AeroNet, which looks at aerosols, to ask these kinds of questions to see if she can improve forecasts with the mixture of PACE data and ground data. And another important part of our program is community engagement. I'll list a couple of the kinds of communities that we foster and try to serve. There's the community of practice, which is basically people who are remote sensing data users, interested in PACE data. It's kind of, in a way, it's kind of everybody that's kind of here. I mean, people who are interested in PACE data or use PACE data, especially those experienced with remote sensing data. We have different events, quarterly meetings, and we also have an email list that we use to help keep everybody informed. We're also part of the science and applications team. This is a competed, proposal competed science team that turns over every, I actually don't know if it's 2 or 3, I'm not sure how many years it is. And we are now on our 3rd science and applications team. And these are the NASA-funded scientists that work on algorithm development, algorithms, and other projects. We also have the early adopters, and I'm sure a lot of you are familiar with them, but I actually did have 2 people ask me about the early adopters program. I didn't have a chance to put in a whole slide on them. But if you were those 2 people, you can check out our website. There's all these fantastic examples, PACE early adopters. Google it, you'll see these fantastic projects that the different early adopters of PACE data are doing. And these are basically researchers and others with applied projects or needs that are teamed with specific stakeholders to develop and apply advanced PACE applications. So this is PACE working in that space between, having a data product and getting somebody on the ground to use it. That's really where the applications program wants to focus. We kind of work across a lot of different communities and user levels, but really right there, that's an important zone in terms of, or the most important zone for our applications work. And then early adopters help us with that. So new in 2000, so coming up next year, Aaron talked a little bit about this. So the early adopters program is really for early adopters. So that's people, pre-launch or, maybe in the first year. And it doesn't mean our early adopters program is going to end. They're always going to be our early adopters. They'll always have that moniker, and we're going to keep working with them as long as they're still doing their projects to see where they go. These stories are extremely useful to us, knowing how an early adopter, evolves from, early in the mission through when data are available and the data mature. And we'll also keep it open to applications. People will just be called applications partners instead of early adopters for future people that want to try to apply for these kinds of partnerships with the PACE program. Let's see, the last thing I want to mention, I won't read through all of these, but if you go to this website, there's different, it gives examples of different kinds of events that our program has had. Workshops like this one, focus sessions, tutorials, town halls. The question I have for you guys is, one of the questions is, we're planning our next events. What would you like to see in terms of, really, especially in terms of maybe focus sessions or ones with specific objectives in mind that you think might be useful. I'm kind of thinking about doing a PACE applications user working group. I haven't been in a user working group. I need to investigate this, but I want to see if it would be something practically useful to our program. If anybody's been in a user working group that they found useful, feel free to tell me about it. I don't actually know much about them. All right, and so that's kind of a quick run through of the PACE applications program and a couple of the things that are coming up ahead. I just want to end with the beloved triangle, the beloved Earth Science to Action triangle or pyramid. And I just want to say that, so the nearly daily global imaging spectroscopy and multi-angular polarimetry of PACE state is really a game changer. We know this. The research and actionable applications for the research and actionable applications utilizing PACE data. Okay, so those of us here that are scientists, we know this, and we've known this for some time, the excitement of PACE data. But here's the question: do most potential end users that could utilize the data in the future to, say, protect public health or influence policy know? Does the general public know? Do leaders know the value of our data? The more people outside of the research science bubble, which is kind of the lower part of this triangle, that know about and tangibly benefit from Earth observation applications, the more opportunity this field is going to have to innovate and continue the cycle of advancing Earth observations and for the science for the benefit of all. And that's what this pyramid and arrow are all about. And that's what this program is all about. And we're excited that we now have PACE data to get to work with. So if you have any questions, I would be glad to take them.